These inequalities with radicals are a little bit tricky. The one thing we need to consider for each of these cases is that there's a domain restriction on the radical. If we start solving it, we square both sides. And that seems like, yeah, that's the answer. All done. And the solution set, it says x can be any number lower than 15. So it could be like 14, 9, 6, 0, -5, -100. But we run into some problems when we get too small, when we get too far left of 15. So if we plug in a big negative number like -10, we could see that'll give us a radical with a negative under it, which is not allowed. So there's going to be some limit to the smallest number. And the smallest number you could plug into this is -1. That'll give us 0. So we're going to have to cut off some of this solution set and cap it at -1 because of the domain restriction of the radical. So that gives us this solution set, all the numbers between -1 and 15. And that's written like that. So, heads up on this. When I see this, I just think it's an expression that says x is between these two numbers. The direction of these, it's always in the same direction, usually pointing to the left. So you'll never see something like that. That's nonsensical. Always in the left. And to read this thing, you don't want to read it like -1 is less than or equal to x is less than or equal to 15. I mean, that's true, but it doesn't really communicate the meaning behind this. It's better to read it from the direction of x. So let me just read the right side. X is a number less than 15. So I'm reading it from the direction of x. But when I do the left side, reading it from the direction of x, I want to say x is greater than -1. So think about that. What does that mean? X is greater than -1. It's to the right of -1. So that just makes a lot more sense than saying -1 is less than x, at least to me. -1 is less than x. I like to say x is greater than -1. All right. But our main point is to solve this thing and then exclude the values in the solution set that are part of the domain restriction. So that's the special consideration we need to make. All right, let's go on to the next one. This one. So there's our solution set. But this one's going the opposite direction. It's going to the right. So we do need to exclude our domain restrictions, which are over here, but they're already excluded. So we don't need to re-exclude. We don't need to come over here and say x has to be greater than -1, because this already excludes this, or already keeps us, all these numbers are already greater than -1. So we'd be like saying the same thing twice if we included that. It's unnecessary. And there's some special considerations. If the right side is a negative, a radical can never be less than a negative because a radical is always positive. Like no matter what you plug in here, it's always going to be a positive number. So if I plug in 4, it's always 2. Like there's no way to make it a negative number. I could try plugging in -4, but that doesn't make -2. It's non-real. No solution. So when you get one like this, less than -4, there's no way to make this negative. Therefore, it can never be lower or less than -4. It will always be greater than -4. Heads up though, if you do attempt to solve this with algebra, nothing will stop you. You'll get a solution set, but it's one of those extraneous solution sets. You're supposed to plug a number from this solution set back in to make sure it works. Like if it's some number less than 15, might be 14 or 14.5 or 4. But if I plug in 14, maybe I should plug in 8. I can see that it doesn't work. 3 is less than -4. So don't fall into that trap. Yeah, if you solve it algebraically, it'll seem like you get an answer, but it'll be wrong. So okay, same concept, but now it's greater than -4. Since this will always be positive, that means that it will always be greater than -4 no matter what, as long as you don't violate the domain restriction. So if you plug in 8 into this one, it'll definitely work. You can plug in any number you want as long as it doesn't make this a radical of a negative number. 0 is okay. You could plug in -1 and get square root of 0. That's okay. Square root of 0 is 0, which is still greater than -4. But if you go a little smaller than that, then it's not going to work. If you plug in -2, you get square root of -1, which is a no-go. It's undefined. So there's our solution set for that last one. Okay, I'm going to do a couple of these. And the ones we were doing before, the radical's already isolated. So I have some steps to do in this one before the radical's isolated. I got to subtract 2 and then divide by 5. So let's see, I get 15 and then divide by 5 is 3. And then I square both sides and I get x is greater than 9. All right. But now I have to consider the domain restriction. I didn't do this before, but one way to get the domain restriction, I mean, you could just look at it, which is probably the easier way. X definitely has to be greater than or equal to 0 for this one. But another way is to just take whatever's under the radical and write this expression. Like in the next one we do, when I do the domain, I'll take whatever's under the radical and I'll say this has to be greater than or equal to 0, and then I'll solve it. And that will be my domain restriction. All right, but I can see my solution set already supersedes this domain restriction. Like I'm already achieving this domain restriction when I say x is greater than 9. I'm not in any danger of including any negative numbers. So here I don't need to incorporate that into my answer. It'll just be x is greater than 9. It's the ones that are less than. That's the one where you'll have that two-sided answer. All right, let's check out the next one. X is less than 152, which means my solution set is heading towards the numbers that could cause me a domain restriction problem, right? I can't get numbers negative or even less than 8. So if I want to calculate the domain restriction, I take whatever's on the radical and I say, hey, that thing, it's got to be bigger than or equal to 0, which means x has to be greater than or equal to 8. So now I have these two definitions, two restrictions on my solution set. So x has to be greater than 8 and less than 152. So I'd write it like this. X is greater than 8 and less than 152. In other words, x is between 8 and 152. If I wanted to check it, I could plug in 8 and just see what happens. And yeah, I can see I get a 0 there. 2 times 0 is 0, which is less than 24. And I could come back and plug in my 152. I get 152 minus 8 is 144. And square root of 144 is 12. 2 times 12 is equal to 24. So I got to make sure I don't have an equal sign there. But anything smaller than 152 will make this radical smaller than 12, which will make the inequality correct. All right. This last one, it's not a square root, so I don't have to do any of those considerations. There's no domain restriction. I don't have to do any of that. I can just solve this algebraically because it's an odd. If it was an even, it would be exactly the same as those the square roots. I'd have to make all those considerations for the domain restriction. Odd roots, no domain restriction, no problem. I guess if you want to, you could just plug that in, experiment with it. Plug in 30, maybe you could plug in 31 and even 29. So 31 should work and 29 shouldn't work.